Good afternoon, everyone. Welcome to the Neo4j Twitch channel and to this will be week 4 of a weekly stream on building web applications with Neo4j and Typescript. So my name is Adam, and today we're going to be looking at authorization. So we'll be adding subscriptions into the API and then granting the user with a free trial, and then using the graph to serve content to the user. So just to recap the project that we have so far. Our client is Neoflix. So Neoflix is a video streaming service that allows you to buy monthly subscriptions to movies and TV shows. So we started in week 1 by creating a project using the Nest command line interface. And as part of this, this project, we created a Neo4j module. And then that Neo4j module is the place where you would interact with Neo4j inside the application. So it provides a few. So it provides a service which gives you some helpful methods for interacting with Neo4j. So, for example, creating read or write sessions or running read or write queries. So for that Neo4j service and the Neo4j module, it's registered with what's called a dynamic module. We created a function which will pull information from the config service, which is a service built into to Nest, to get the information from the .env file. So, for example, the Neo4j scheme, the host port, username, and password. Use that to build up a connection string, which would then build a Neo4j driver, and then that driver is then injected into the module. In week 2, we imported the data in based on some CSV files from a dataset found on Kaggle. The resulting dataset that we've got is this. So we have everything basically revolving around a movie. So a movie is listed in one or more genres. Can belong to a collection. So, for example, the Toy Story collection or the Matrix collection. It's produced within a country and produced by a production company. The movie has an original language and is also spoken in many other languages as well. And it also has keywords. We have person nodes which are related to the movies, so either the cast or crew for a movie. And we also have a few 100,000 users in there, each of which is rated 1 or more movies with a rating between 1 and 5. Week 3, we created an auth module. So basically, the whole session revolved around allowing the API to identify who a user is. So we created a auth controller. We created a root handler to register a user. That root handler would take what's called a data transfer object, or a DTO. And basically that validates the request as it comes into the user. So, for example, we're saying that we want a username and password to both be not empty. We also want a date of birth, first name and last name. Main.js, we registered that global validation pipe. So every request that comes through will be passed through that pipe, and then Nest will check for DTOs and then validate them based on that information. And then the auth controller will then pass on the creating of a user to the create user service, which itself communicates with Neo4j by running a Cypher query through the Neo4j service that we've injected in. There are also routes for a route for logging in. So the register route and the login route both produced a JWT or JOT or JSON Web Token. So this is created using libraries provided by the Passport library. The JWT auth guard takes the token, which is generated using the auth service, and then validates the information inside that JSON Web Token. If the token is valid, then the user node is then retrieved and then added to the database using the JWT strategy. So in this class, the Nest.js Passport and Passport JWT, a combination of the two, will take the token from the auth header, so that's as a bearer token, and it will check the signature based on the secret or key that we provided from the config service. And then if everything is okay, then we look for the user by the email address and the email contained inside the payload for the JOT token. If we can't find the user, then we throw an unauthorized exception. Otherwise, what this strategy will do is add the add the user object to the request object. And then we created a get user route handler. So if somebody goes to /auth/user with a valid token, we return certain pieces of information about the user based on their properties. Inside the test, we have an end-to-end test, which basically tests everything from start to finish. So we have a group here for describing the auth register route. So what happens if we have a invalid request? So we're testing the validation pipe. It should return a 200 successful when the registration is good. The login route should return a 401 if the username and password are incorrect, or should return a 201 because it created a new token. And then what we do is we take that token and then we check that inside the get auth user route. So we pass through the same token as a bearer for the authorization header. And then we expect that the email will be the same email address as we signed up with, and then the password should be undefined. Basically, we shouldn't be exposing the password either in encrypted or unencrypted form. All of the code so far is up on GitHub, so github.com/adam-cowley/twitch-project. So if you have any comments, suggestions on the session so far, or if there's any features that you'd like to be added or built as part of the series, then feel free to create a GitHub issue there. There's also a write-up of all the sessions on the Neo4j developer blog on Medium, so medium.com/Neo4j. So as you can see, I published this yesterday for authentication, but we've also got the original post for the first episode in the series. Cool, so that's housekeeping out of the way. So now we'll get on to the actual code itself. So today we're going to be looking at authorization. So previously we looked at authentication, so how can we verify that a user is who they say they are? So they do that with a email address and password, or with a token that we've issued to them. So now we're going to be looking instead at authorization. So to illustrate the difference between the two, let's take a scenario from Neoflix. So when a user registers for Neoflix, they will automatically be given a 30-day free trial, which gives them access to all the content on the website for 30 days. And then after that trial ends, they'll be required to buy a subscription. So that'll be like an auto-renewing subscription that renews every month. And unless the user cancels the subscription, then they'll be given access to certain things. So the fact that the user has valid credentials, so in our case, the username and password, means that we can correctly authenticate them. But although they have valid credentials, that they may or may not be able to access certain content based on the subscriptions that they've purchased. So what we're going to do today is we're going to load some packages into the database and then add the subscription logic to the API. In order to add this to the API, the first thing we'll need to do is to add the concept of packages and subscriptions to the database. Each of the packages and the subscriptions as well will be identified by a unique ID. So what we can do is we can create a unique constraint on them. So for example, for the package, we could say create constraint on p package, and then assert that p.id is unique. So this will ensure that ID is unique for every node in the database with a package label on there, but also mean that when we do our lookups in the database, that we use an index rather than looking for every package. So for the packages, we're going to have 5 or 6 packages, so it's not too much of a problem. But if you think of it in terms of looking at millions of users, if you need to go through a million users to find a user by its user ID, that's going to be a really difficult task. Whereas if we create an index on the ID, then we can go directly to that node. So I can do the same thing for subscription as well. So I could just basically copy and paste. So for the subscription, assert that subscription ID is unique. Cool. And in the repo, I've created a CSV file, so packages.csv file. So this contains the 6 test packages that we're going to create for users. And so it goes all the way down from a children's package at $4.99 a month, all the way up to the ultimate. So each of the packages has an ID and a name. It has a price, which is a float, the number of days that the package will be valid for before it auto-renews. And then to illustrate the idea of authorization, each of these packages will provide access to one or more genres. So similar to kind of like a Sky Movies subscription, the package itself will provide access to movies that are grouped inside a genre. So these are pipe limited, so I can load those into Neo4j using load CSV. So what I can do is I can either use the local version, or I can use load CSV on the raw file, so over HTTPS. So if I say, for example, load CSV with headers from that file as row, and if I return row, we should see now we have a row object which has the ID, the days, the name, the genres, and the price. So as I mentioned in a previous session, all of these are strings at the moment. So when you load data in with load CSV, everything is a string by default. So we're going to have to use the functions inside Cypher to coerce it into the right format. So for example, the ID we can use to integer, and then for the price we can use to float. Cool. So these now don't have speech marks around them, so they are in those formats. So one thing that we haven't really discussed before is a Neo4j temporal types. So if you are interested, then you can go to my blog, adamkelly.co.uk, and there should be a post somewhere on temporal types. So using temporal types in Neo4j. So these were introduced in Neo4j 3.4, so we're 4.1 now. So this is well, it's kind of 2 years old. But yeah, so essentially we introduced these native temporal types. So we have dates, times, and durations. So in terms of the expiry date and time, we've used that already with our subscriptions. So subscriptions have a date time property. And so basically what we're going to do is we're going to create a duration type. And essentially this just is like a Java duration, which represents the amount of time passed between two events. So in our case, we're looking at a number of days, and we can take that from the column. But for example, we can say we can have days, years, months, and days, and then hours, minutes, and seconds. So the duration looks a bit like this. So if we say return duration, and I can say that it's a period of, say for example, 2 years. So that then converts that into 24 months. So it works in months, days, and then time. So I could say, for example, 2 days, 3 months, and 4 days, and then I'll split that out into 27 months and 4 days. For time, we then split that with a T. So I could say, for example, 12 hours, 34 minutes, and 56 seconds, and then it'll add it up on there. So in our case, we're only interested in the number of days essentially. So the days column from there. So we can use the duration function in Cypher, and then we're basically saying that it's p and then row dot days d. Cool. Okay, so in order to load that file in, so we can now I have the right information, so we can merge a package node, so p package. We're going to merge that on the ID, so row.id. And we want to set the name, so p.name equals row.name. p.duration is the duration that we just created. And then the p.price should be row.price, which is cast as a float. And then, so the one thing that we haven't done so far is we haven't looked at the genres. So we've got row.genres. So this is a string which is split by pipes. So we can use the split function in Cypher. So we split the row.genres by a pipe, and then that will give us an array. Cool. So we want to say for each, and then name in split row.genres by a pipe. Pipe that into the next function, which will be merge a genre by the name of name, and then merge package provides access to the genre. And if I return star, so we've now got the different genres in there. So we've got the children's, we've got bronze, silver, gold, platinum, and ultimate. And then if I double click on these, then we should see the relationships that are created between the genres there. Cool. So now we've got the data in here. We can traverse through the graph to basically to find out what the user has access to. So in order to see this, we'd create a subscription, and then the path would be something like this. So we'd have a user node, as a subscription to a subscription node and then you buy the subscription for a package. So for package. Then that package would provide access to a genre. And then, so then we've got the movies, which are in genre. So essentially, we can start off at the user based on their ID. So that ID will be a UID, which we create in the UI. And then go through the subscription, filtering down the subscriptions. So the expires at is greater than or equal to the current date time. And then we can go from there essentially. So we're basically using different variations of this pattern all the way through the session today. Cool. And I guess like also to demonstrate the ease of a Cypher query and the power of a Cypher query. What we can do as well is as well as provide an access to a genre, we could also do things like provide access to a list. But what we're going to do right now is provide access to a production company. So there may be, for example, some genres that you don't have access to. Like for example, we have like documentaries and music. So all these over here, which this bronze package doesn't provide access to. But we may want to provide them access to different things. What we can do as well is we can like identify some production companies, check out their genres, and then create another relationship between that bronze package and particular nodes. Because instead of going through the pattern, this genre and then to movie, so what we could do instead is change this up. So it could go through this one, or it could be provides access to the production company. So think of kind of like a Disney Plus type thing, and then that movie will be so that will be produced by. So we can merge the two patterns together. So it will be provide access to something. So we don't really care what that is at the moment. So if we're not really interested in what that is, then we can just leave that blank. We can also add like a variable in there, and then we can say that this relationship will either be in genre, or we can introduce another one using a pipe and then say produced by. And then basically that's all we need to do in order to add this this production company theory into the path. So for example, we'll find some production companies and then some movies which are produced by that company. That will be in a genre of G. And then we can say, so basically what we want to do is find, so let's say anything that isn't in this list. So this will be the one for the bronze. So we can say, so with P, and then a collection, so collect G dot name genres, and then let's just do a distinct count of the movies, and then we'll say where none of the genres where G is in, we'll just split that string. So basically for this collection, we want to make sure that none of these values are inside there. That's the bronze one, and then we'll say return style limit 10. Cool. So there's a few options for us. So Classico, which give science fiction, mystery, and thrillers, or produce science fiction, mystery, and thrillers. So Lost Hooligans, maybe not something we want to give to anybody. So we have, for example, we have documentaries from SIAC Film Production, Blue Horse Films. So these seem like good candidates, things that we can recommend to anybody. So the IDs of those are, if we take that one, so 9.3. Take 8.3. So I can match the package where the ID of the package is 2. So I'll give us the bronze one, and then match C, which be production company, where C dot ID is in these values, and then create a relationship between the P. So again, that provides access to. So we could call out something else if we wanted to, but for now we don't really need to worry too much about that. So if we run that, so we've now got 3 relationships created. So let's now create a test user and a test subscription for that bronze package. So if we match the package where the ID is 2, so then create the user node. So just give this like an ID of test, so I can find this later on. So email, let's say bronze.user@neoflix.com. I've not actually checked if that's a real domain. Maybe we should put out an example. First name is test, and then last name user. And then we want to create the subscription as well. So create user as subscription, S subscription. So ID with this again test, and then we'll say expires at. So the current date time, and then we can add a duration to a date time to create a date in the future. We can -1 away, and let's add 2 days to that, and then that subscription is for package P. Okay, so we've already got a user there. So that proves that our constraints work. So let's call this test 2. Cool. So now we have this user. So this bronze example.com. First name is test. Last name is user. So we now have this subscription with an ID of test, which it expires on the 23rd at 12:35:41, and it's for this package. So now we can see from this package, it will provide access to the dark green nodes, which are the genres, and also provide access to films that are produced by Blue Horse Films and Cinemax Real Life. Cool. So what we can do to test this out is we can basically find some films, some movies at random. Then we can basically test that that path exists from the movie through either the production company or the genre to a package and then to a subscription and back to the user. So I would validate how that works. So if we match a user with the ID of test2, and then we find the has subscription to a subscription for package P, and then we want to filter that down basically to say that where that subscription expires at is greater than or equal to the current date time. Then we'll match the movie. So we'll say that with the user subscription package and then the movie, and then just order that by rands. So just get 10 random ones. Then we can return the movie ID, the movie title. And then, so basically what we can do is then we can use the exists function, so or the exist predicate, to work out whether there's a path that exists between this movie. So the path that we want is from the movie node M. So it's either in genre or produced by something. We don't really care what that is. So in a in a predicate, you can introduce new values, so it doesn't. So we can't define something here. If we wanted to introduce a value, we then move that up into the match clause. Maybe we do like an optional match there. And then basically what we want to do is to find the provides access to that P node there. And we'll give that an alias, so can access. Brilliant. So the next thing for us to do is to then add the subscriptions to the API. So we'll jump over into Nest to do that. So to add the subscription functionality, what we want to do is we want to add a new module in Nest, and then we want to create a new service which will interact with that. So I can use the Nest CLI again to create that. So I can Nest G or generate, and then MO or module subscription, and then that should create us a new subscription folder, and then the subscription module there, and then we want to add the service as well. Type of user, which is exported by the user service. So we'll always get this type here. So what we can do inside here is we can say that the first argument should be an instance of the user. So that will always ensure that within the application, when you create a subscription, that user will already exist. Just to basically to make sure that we don't do too many sort of back and forth communications between the database, we can just supply the package ID, because that's something that's going to come as part of the either request body or like a parameter in the request URL. So we'll always have that package ID, which will be so in this case it'll be a number. And then, so what we could do as well is we could say that the days parameter will be a number defaulted to null. And then what we can do is basically say that we can override inside the application how many days that that subscription is active for. So there may be some sort of admin module somewhere later on where you add an extra 5-10 days to a subscription. So we can enforce that there. This function will return a subscription node, but we need to define that. So we'll do the same thing as we did with the user. So we'll export a type called subscription, and we'll just default that to be a Neo4j node. Cool. So inside this subscription service, what we're going to want to do is to interact with Neo4j. So in the constructor, we can inject a private reader-only Neo4j service, and then Nest will inject that for us. So basically, yeah, we want to create this from the user as a subscription to a package. So basically, we want the user ID. So we extract the user ID, which will be a string, and then that will be from user.properties.id. So that we want to cast as a record. The key is a string, and then values any. And then, so basically, we wanted to create a result. So I want to make that async. So we want to await this .neo4j service.write. So it's a write query to the database. We want to find the user, where the ID is the user ID parameter. So we pass the parameter through as the an object of parameters as a second argument. So we can say user ID there. We also want the package ID. The user will purchase a subscription, and then that subscription needs to have an ID. So we'll assign that to be a random UUID, and then the expires at will be a date time. So it'll be the current date time, and then we want to add the duration on there. So bearing in mind that we can either have the number of days, or it can be not supplied. So what we can do inside there is say that it's well, we can use a case statement. So case when days is not null. So I can pass that through there. Then we want to build a duration. So p days d. Else we just want to take the default package duration, so that would be like the 30 days that were created, or 90 days for the ultimate package. And then that subscription is for package p. And then we want to return that the s out. And then what we want to do is return res.records 0, so it'll be the first record there. And then we want to get the S item on that record. Cool. So just a note at this point on working with integers. So basically, there's a disparity between the integers that are used inside Java and inside Neo4j under the hood, and then the integers that are used by JavaScript. But essentially, the Neo4j type system itself uses a 64-bit integer, which has a considerably higher range than the JavaScript integer. So if I create an integer which is anything higher than this, then it's going to basically start to cause issues. The solution for that inside the Neo4j driver is to expose an int function, which basically converts it into an object which the Neo4j driver understands. And then when the data then comes back out, we have this instance of a Neo4j integer, not a JavaScript integer, and then we call toNumber on that integer in order to hydrate that back out. If it's within the safe range, so the in between min and max safe integer, then it will return it as an integer, otherwise it will just return it as a string. So for that reason, what I will do is I will add an int function. So it'd just be a way of accessing the int function that's exported from Neo4j. So the value that gets added into that will be a number, and then we just want to return the int function. Cool, yep, so we have this int function there, and then I've just imported that in from the Neo4j driver. Our other option is to say, for example, to use the toInteger function inside the Cypher query itself. Cool, so if I start that, there shouldn't be any errors at the moment. Okay, so there's an async function should return a promise, which resolves to a subscription, so that should solve that problem. Perfect, so everything's running, no surprises there so far. So the next thing we want to do is to hook this into the Auth module, so that then we can use it inside the in the Auth controller. So in the Auth module, I also want to import in the subscription module. So then I can inject the subscription service into the Auth controller. So subscription service. So the one thing we haven't done so far inside the database, so we've got the different packages, but we don't at the moment have a package for a free trial. So what I'll do is I'll just create a new one for that. So we'll give that a package ID of 0. And then we'll give that a name of free trial. Price is nothing, and then it lasts for 30 days by default. So I can say that with that p node, so I just create we'll match all of the genres in the database, and then create the relationship between the package and the genre to say that the package provides access to that genre. Cool. So if I take a look at this again, and I look at the free trial, that should now have access to all 20. So I can check that by saying match package ID of 0, and then I can return the size of P provides access to something. 20, cool. So that now has access to all 20. So now we can hook that into the post register method. So we've created the user, we then get a user object return from there. So now what I can just say is this sort of .subscription service dot create subscription. The user is user, package ID is 0, and then we'll leave the number of days. What we want to do is to await that, so the method will run before the token is then generated. Cool. So there's a slight caveat to this piece of code. So right now, the way that we're using the driver is that we are basically running what are called Autocommit Transactions. So when you run something in the Neo4j service, we basically create a new session, and then we use session.run. So what that does is that will open up a transaction, it will run the query, and then it will commit the transaction. So there's like an overhead there when you commit the transaction, because that information needs to be written to the transaction log inside Neo4j. Ideally, what we want to do with this at the moment is we want to create a transaction and then run all of these queries inside the context of one transaction. I won't do that for now. That will be a topic for another episode, so we'll sort that out at a later date. Cool. So if I run the end-to-end tests that we used last week using npm run test e2e, so everything should pass at the moment. So we've not really changed too much. Oops, so it's failing at the moment. Here we go. So the Nest can't resolve the dependencies of the auth controller, so it doesn't know what the subscription service is. So what I need to do is in the subscription module, I want to export that. Cool, so let's try that again. Okay, so different error this time. We're getting a 500 error, so that's my fault. That's the cipher query isn't working. So we need end there at the end of the case statement. Right, so third time lucky. Let's see what we get. Awesome. So the code that we are running, everything works. We've not introduced any bugs or any breaking changes into that API. Everything just works under the hood, which is perfect. Cool. So now we've got a subscription. The next thing to do, we'll create a genres endpoints. So then we can provide the UI with access to view the catalog. Cool. So what I want to do now is to create a new module. Call that the genre module. We want to create the service as well for the genre. And additionally, we want to create a controller. Cool. So the genre controller we'll be using the genre service, so we'll add that in as in the constructor. And then so we want to guard this route with the JWT auth guard, and then that'll allow us to get an instance of the user and then pass that through to the genre service. Then we traverse through the graph to find out whether they can access the resource or not. So we want the JWT auth guard. So this is a GET request to /genres, so /genre. And then we want async get list. So we want to get the request. And then we can take the request.user, which gives us the user object. So in the genre service, what we want to do is we want to get the genres listed from Neo4j. So again, we're going to be using the Neo4j service. Neo4j service. And we want a method to get genres for user. And then so that have one argument, which will be the user. So this will return a promise. And then so that the API will be returning a list of genres. So we'll create a new type of genre. So previously what we've been doing is just mapping things directly to Neo4j nodes. So instead, what we should do is to create an interface. We'll call that genre. And then we can sort of guarantee that this has an ID property, which is a string. Sorry, the ID is a number, and then name is string. Cool. So what we want to do is to call Neo4j. So we want to await this.neo4j service, and then we want to read from the database. And service, I can copy over that user ID. I will match the user based on the ID. I want to find the subscriptions, which are for a package P, which provides access to the genre. I want to make sure that the expires at property is greater than or equal to the current date and time, and then return the genre, ordered by the name of the genre in ascending order. So there's some processing we need to do now to extract the information that we want out of the nodes. So we will return res.records.map. So for each of the rows, we want to return an object. So basically, we want the ID, which will be row.get g.properties.id, and because this is an integer, we need to call toNumber on that. And then what we can do is just use the spread operator on the properties of the node, just to return everything from that node. So we're guaranteeing that we've got the ID and the name, but there could be more properties on there. Cool, so in the genre controller, what we can do is we can use the genre service to get the genres for the user with a request.user. We could just return that straight out. So in order to test this, we can go back into the end-to-end tests. We can add a new group, describe get/genres. And by adding it just inside this, we can basically use the information that we have here. So we can basically copy the first two tests from get auth user, because we basically want to guarantee that there's nothing returned from the API if there's no user record. And if there is a correct token provided, then we basically want to assert that they can access all 20 genres. So the length of the body, so the array should be equal to 20. And then we want to make sure that for each of the items, that we expect that so basically we want to ensure that we have the ID and the name for each one. So we can take the keys of the objects. And we want this to equal. We expect an array which contains ID and then name. So if you run those tests again, no, so res.body is undefined. So if we log res.body to see what we're getting out of that. Okay, so that was me. So if we change that to be genres, then we're hitting the right endpoint. And perfect. So you can see that that last test is now passing. So we've got all of the different genres there, and we've got the ID and the name. So run that again just to ensure that these two endpoints work as well. Perfect, all good. Awesome. So next, add in videos that are inside a genre. So basically, we want to provide a list of movies within a particular genre that that the subscription provides the user access to. So in the genre controller, we're going to add another route. So again, we want to use the JWT auth guard. We want to do a GET request. to /genres/ and then an ID. So this would be, for example, genres /28 for action. And then we want to define a function, so get genres. So one thing I haven't done already that we can do is we can use, okay, so we kind of used it for this request, but we can use decorators to decorate the inputs of the route handler. For example, we can say that we want the request, and then Nest will, using that decorator, find the request objects and then pass through to us. So we want to take the ID parameter as well from the URL, so we can use a decorator for that as well. So in this case, we would do a param, which again comes from Nest Common. We provide that. Well, the first argument is the name, and then we can say, for example, that's going to be the genre ID. Cool. So in our case, this is a number rather than a string. So by default, everything will be read out as a string. So the additional parameters that you pass through to this param decorator are pipes. So we looked through pipes in the last session, and we used it to basically create a validation pipe which validated the request. So what we can do is we can use the pass int pipe. And then basically what this will do is it will pass the value as an int. So we want an instance of that. And then we can also use things like the default value pipe, which we'll go into. So that's exactly what we need for the request, but we may need some extra information. So the user may click on some sort of pagination inside the UI. In which case we should be looking for things like the page number. They may want to view more or less results, so they may want to change the limit. So we can set a default limit. So we can do that as well using query parameters. So we can use the @query decorator. And then say, for example, we want the order by property. So this is optional, so we can use the default value pipe to give this a default value of title. So by default, order by the title, but you may want to order by the ID as well. And this will be, we'll call this order by, and then that will be a string. This will be a number. And then we can take the page as well. So this will be a pass int pipe, and then we want it to have a new default value pipe as well. So by default, it would be page 1. Page, which would be a number. We can do the same thing with limit. So we want to pass that to be an int as well, and we want the default to be 10. Limit. So now we should pass the responsibility of the return back to the genre service. So basically what we want to do is to create a new method in there. So get movies for genre. So if we implement this, we want async get movies for genre. The first thing I'm going to pass through is the user from the request. I want the genre ID, which will be a number. I want order by, which will be a string, default being title. And then we want the limit, which will be a number. And then we want the page, which will be a number. Cool. Again, so we're going through this this same pattern as above. So we're going through from the user to a genre, and then we'll find the movies from there. So I can take this, and I can say that we want to find movies that are in genre. movie, and I want to return M. Order by M dot. So title in ascending order. Limit, and then we want to skip as well if more than one page. Cool. So there's a few things we need to do here. So the responsibility of working out how many results and the pagination shouldn't be done by the controller. It should be done by the service. So we'll add a little bit of logic inside here to convert the page number into a skip value. So for example, we can say that skip will be an integer. And then what we want to do is say that page -1 times the limit. The limit will be int, or converted to an integer. Next thing we want to do is add the genre ID in there as well. And then that will be an int. Cool. So we've got the fact that the subscription is going to be an active subscription. There's another thing that we want to add in there as well. So inside the database, we've got some of these movies which are marked as adults. So basically, we can assume that those movies aren't suitable for people under the age of 18. So what we can do is also do a check to say that the date of birth is less than or equal to basically 18 years ago. So date, time, minus a duration of 18 years, or that the movie is not an adult movie. So that will filter out inappropriate content based on age. So we may want to add some extra information to the UI. So for example, you can use like a pattern comprehension here to get the genres that it's listed in. G and then G genres. We may want to do the same thing for the cast. So a person who is in the cast for that movie. P, and then just to not overload the UI will return more detail than we need to. We'll just say we'll take the first 5 using the spread operator in there. And then we'll say that as cast. And then so in the return, we just need to have manipulation. So we can say that we'll use the spread operator again to get the properties, then we'll convert the number to be a string. Then for the genres, we can just say row.get genres. The same thing for the cast. Cool. If we then implement that into this controller, so we want the request.user. I want the ID of the genre, order by, limit, and then page number. Right, everything looks good there. So if we then go back to the end-to-end test, and we'll create a new group. Actually, what we can do is we can copy that down. Cool, and actually what we could do here is inside here we could say genre ID, and then what we could do is we could just take one of these values, just so we know we're looking at an actual genre. So when we get into the get genres, we could say that genre ID is res.body0 .id. Move that down to the bottom. So we are assigning Genre for the next test. Cool, so we're testing genre /ID, and then we can add it into here and here and here. So again, we're testing that the auth guard works for the first two queries, and then for the third one, we should be getting some details there. So if I just log what's going on there. Okay, so we've got 400 bad requests there when we wanted 200. So numeric string is expected. What we need to do is switch these around. So if I change these around out of my test. Okay, so now there's a different error there. So again, there's a problem with the cipher query. So that should be an underscore. Perfect, so now we've got a list of movies in there. So in this case, 10 Cent Pistol. We have all the detail there. We have genre and the cast there, which is returned. So there's still a few things in there that, for example, we have this release date, which is a Neo4j date at the moment. So in a future episode, we'll go through and we'll sort those out. Won't worry too much about that for now. But the response is okay for the moment. There's a few more things that we could test. So for example, we could test that limit is applied correctly. So we just create another method here. So for example, like at the moment, it should be 10. But then if we supply limit 20, then it should be 20. So we could test for things like that. I won't worry too much about that now. That code will be up on GitHub. I'll do that offline. Cool, but yeah, I mean that's enough for today's session. Thank you for everybody who was stuck there all the way through. Basically, in this session, we've covered some basic authentication using the structure of the graph to work out what a user can and cannot see. So when a user registered, they'll now be given a 30-day description to package 0, free package there. And then we use that structure and the genre service in order to traverse the graph to find out what they can and cannot see. So I mentioned some issues that we have around like Neo4j specific data types that are still being returned at the moment. We'll look at that in a later episode. But for now, if you have any comments, any questions, if there's anything you'd like to see, feel free to get in touch, open up an issue on the GitHub repo. Otherwise, I'll see you next week at the same time.